Next concept is what is ionic polarization and what is the expression for ionic polarizability. This is small concept. Okay, it will take around 5 to 10 minutes only. Electronic polarization. Just this orientation polarization is the definition. Okay, right. Now I am going to explain what is electronic polarization. Yes, without application of field, in a ion. Ion means, for example, you take sodium chloride. In sodium chloride, Na plus ion is there, Cl minus ion is there. Okay, so this is a positive ion, Na plus ion. This is Cl minus ion, negative ion, cation, anion. Okay, so first of all, ionic polarization only takes place in ionic solids only. For example, NaCl, CaCl, BaCl, like that. Okay, so so it will take place in ionic solids only. Normally, without application of electric field, a positive charge, negative charge coincides with each other. Generally, let us say they are separated by certain distance here. But let us assume a positive charge and negative charge coincides with each other. Now, due to the application of electric field, what happens, due to the application of electric field, this positive ion will get displaced. This positive ion get displaced in the direction of electric field. This is the direction of electric field. So, if from positive ion get displaced in the direction of electric field, this negative ion will get displaced in a direction of electric dipole and form a ionic dipole. This is called as ionic dipole. So what is the distance of separation between a positive ion and negative ion? X1 plus X2. So X1 is the separation of positive ion, X2 from center. From center, the negative ion got separated by a distance X2. So the total distance between a positive ion and negative ion is X1 plus X2. So positive ion, negative ion separated by a distance X1 plus X2. So it forms a ionic dipole. Yes, this is called as ionic polarization. That's it. So what is ionic polarization? Formation of a ionic dipole in the direction of electric field due to the application of a field is called as what? Ionic polarization. And we need to derive an expression for ionic polarizability, alpha suffix I, alpha E, electronic polarizability, alpha I, ionic polarizability. It's a small derivation. What is the formula for dipole moment? Dipole moment is the product of charge. Here plus charge minus charge is there. The magnitude of the charge is E, plus E minus E. So it is the product of magnitude of charge E. Either you take positive charge or negative charge. The magnitude of charge is E. This is plus E, this is minus E, into distance of separation between two charges. What is the distance of separation between two charges? X1 plus X2. Yes, positive charge got displaced by X1 from center, negative charge got displaced due to by a distance X2. Okay, then total distance of separation is X1 plus X2 due to the application of electric field. So X1 plus X2. So E, magnitude of charge, into separation of charges between the dipole ions is X1 plus X2. So this is a dipole moment. Sir, is it clear? Dipole moment expression does we got? No, we doesn't got completely, because we don't know the value of X1 plus X2. If we know the value of X1 plus X2, then expression is over. So for the purpose, what we are doing is F proportional to X1, restoring force. What is this F, sir? F is restoring force, is directly proportional to X1. For example, what is this X1? What is this restoring force, sir? Yes, this applied electric field create, for example, you take a rubber band. So if you stretch the rubber band, what happens? It got this, that means it got stretched. But if you leave the leave the rubber band to itself, then what happens? It come back to its original position. What is there inside? Restoring force. So a restore, as we apply mechanical force on the rubber band, alternatively a restoring force will be developed inside the rubber band. If you apply small force, small restoring force is there. If you apply large mechanical force on the rubber band, a large restoring force is developed inside the rubber band also. Okay, so the same concept applied here. Okay, So the restoring force means what? So this electric field apply a force on positive charge and negative charge from its original position. This is the original position. This is the actually displaced position. Due to the application of electric field, some force is acting on plus and minus charges. This in turn create what force inside and dipole? Restoring force. This restoring force try to bring back the dipole to original position. Actually they are now separated by x1 plus x2. Okay, but a restoring force developed inside between these two charges, and it try to bring back these two dipoles to its original position. Okay, so this restoring force developed is directly proportional to displacement. So if you stretch the rubber band small, then the restoring force developed is also small. So that means if you stretch the rubber band to small 1 centimeter, then the restoring force is small. If you stretch the rubber band to 10 centimeters, the restoring force is more. So the restoring force is directly proportional to displacement. Here first ion displaced, positive ion displaced. Here you see positive ion displaced a distance x1, negative ion displaced a distance x2. So F proportional to x1 for positive ion, F proportional to x2 for negative ion. If you take this proportionality, you will get a constant beta 1. If you take out this proportionality, you will get a constant beta 2. From this, what is the value of x1? F by beta 1. From this expression, what is the value of x2? F by beta 2. So we got x1 and x2 values. We got x1 and x2 values. So here what is beta 1 and what is beta 2? Actually beta 1 and beta 2 are proportionality constants, but they depends upon the two factors. One is mass of the ion and second one is the square of the angular frequency. That is different concept. Leave this, just remember those two concepts. So beta 1, this proportionality constant depends upon the two factors. One is mass, another one is omega naught square, square of the angular frequency. Yes, what is angular frequency? What is that concept? What is their dependency? That is another topic. Okay, just you leave. Just this is the dependency. Okay. Yes, beta 1 is equal to if we add these two, you would get this expression. What is this expression? Beta 1 is equal to mass of the positive ion into omega naught square. What is omega naught square? Square of the angular frequency. Similarly, beta 2 is equal to capital M, mass of the negative ion into omega naught square. So here we got beta 1 value, this denominator beta 1 and beta 2. Substitute in that above expression. X1 is equal to F by beta 1. Beta 1 means M omega naught square. Yes. X1 is equal to F by M omega naught square. X2 is equal to F by capital M omega naught square, where capital M is the mass of the negative ion and small m is the mass of the positive ion. So X1 plus X2 is equal to what it becomes? F by M omega naught square plus F by M omega naught square. If you take common as capital F by omega naught square, you would get 1 by small m plus 1 by capital M. So finally, what is the here once again you can write F is equal to EQ. So F is equal to E. E means applied electric field into charge Q. Q here charge is what? E. Q badu instead of Q what we written E. Okay, so instead of F I can write E into E. Okay, E into E by omega naught square. Why you retain E into E? It's a general expression for F equal to EQ. Here E is E, applied electric field, into Q, charge. Here charge is E. So E by omega naught square into 1 by small m plus 1 by capital M. So here mu I is equals to, go back to the last expression. Okay, mu I is equal to, what is the form? Electric ionic dipole moment is equal to E into x1 plus x2. Ionic dipole moment is equal to charge into x1 plus x2. Just stick to that equation. Okay, mu I is equal to E into x1 plus x2. E into x1 plus x2. What is x1 plus x2 value? This value. E by omega naught square into 1 by small m plus 1 by capital M. Here small e into small e is equal to what? E square into E divided by omega naught square into 1 by small m plus M. Yes, if you brought this E value to this denom opposite of the equation, okay, E, if it comes to this side, what it becomes? Mu by mu I divided by E is equal to E square by omega naught square. But we know Dipole moment per unit electric field is equal to what? Polarizability. Which polarizability? Ionic polarizability. So ionic polarizability is equal to mu by E is equal to E square by omega naught square into 1 by smaller plus 1 by capital M. This is the expression for ionic polarizability. This is the